morning, afternoon, evening, or even night, depending on when you are watching the video. This is video 3 for the 231 applied electricity. I want to discuss resistor color coding, though I've discussed it during one of our Zoom meeting before. Let me check it in our book. Resistor coding. This is in chapter 2. We have 4 bars. On a resistor. This end, the bar is closer to this end. At this end, the bar is far. It is from this end where the first bar is the closest that we start counting from. We count this as band 1, band 2, band 3, and then band 4. How do you know where to start counting from? You will know by seeing which end we have the shortest gap between the bar, between the band and the end. It is at this end, so you are starting there. So when you see the first band, you see the color, the second band the color, the third band the color, and the fourth. When you now come here, you see each color has a code. Black is 0, orange is 3, blue is 6, white is 9. The under tolerance, 5% means gold, 10% means silver, 20% means no color band. Now, the way we do it is this. Let me go back to the board. The first band, the second band, the third band, and the fourth band. Let me say this is A, this is B, this is C, and this is D. The figure, the resistance is going to be AB times 10 raised to power C with D percent tolerance. Coming. Is it single L or double L? Tolerance. So, for example, if this is 2, this is 3, this is 4, and this is 5%. So our result, this is the general, isn't it? And this can be interpreted as 2, 3 times 10 raised to power 4 plus or minus 5%. What does that mean? That means, let me give you an example. If this figure is 100 plus or minus 5%, 5% of 100, 5% of 100 equals what? Equals 5. Equals 5. And then that means this figure will range 100 plus or minus 5. That would be 95 to 105. That means it can be any figure between it. It can be 95, it can be 96, it can be 100, it can be 101, it can be 105. Understand? Because the resistance may vary. It may not be a fixed something. It may be fixed, all things being equal, if the resistor is good, if it has not been damaged. But there can be some wear and tear that can make the resistance to be different from that 100. And it can be like that. For example, let me clean the board. If you have 100 plus or minus 20%. 20% of 100, no, let me say, if you want 200, 20% of 200 is what? That would have been 40. Am I right? That would have been 40. And that means this is 200 plus or minus 40. And that means this is a figure between 160 to 240. It can be 200 plus 40 or minus 40. That is the idea of tolerance. So let's take some examples. Okay, we have here band 1 is orange, band 2 is blue 6, and band 3 is 5. That means that's 36 times 10 raised to power 5. 36 and 5 zeros. That's 10 raised to power 5 plus or minus 10%. This 36 times 10 raised to power 5. Let's calculate. They say it is what? It's 10%. If I calculate 10% of this, that will give me 36 times 10 raised to power 4. And that will mean that my value can vary from 36 times 10 raised to power 5 minus 36 times 10 raised to power 4 up to where? Up to 36 times 10 raised to power 5 plus 36 times 10 raised to power 4. It is minus tolerance to plus tolerance. The figure minus tolerance or the figure plus tolerance. It will vary in between that. You can get the actual figures. So they are giving an example here, example 2.6. Please look at it. First band is brown, that is 1. Second band is 0, that is 10. Orange is 3, that is 10,000, 10 kilo ohm. No other band. That means 20% tolerance. They have calculated it for you here. It's either 10,000 plus 2,000 because 20% is 2,000 and 10,000 minus 2,000. The resistance lies between this and that. That's what we have explained. Let me discuss conductors and insulators. Conductors are good conductors of electricity. Insulators are poor conductors of electricity. Example of conductors: copper, aluminium, and so on and so forth. Insulators: glass, rubber. Both are useful. Some will conduct electricity, some will act as insulator. Like this one, for example, there is conductor inside and the insulator is used so that somebody will not be subjected to electrical shock. Summary of it. This book is good. It will give you summary of important formula. With this, we have come to the end of chapter 2. No, okay. Terms and concepts: current, source, load, electric charge, resistance, Ohm's law, and you have exercises. So thank you for listening. This is the end of our video 3. We will do more. Thank you very much.